I'm new to Airflow, Airflow is hard, I don't know where to start, what is a DAG, how can I create data pipeline, and how can I code my first task? I mean, all of those questions, I don't know where should I start. Well, I've asked myself all of those questions when I started to use Airflow, but guess what? You've come to the right place. In this video, you are going to discover how to code your first data pipeline. My name is Mark Lomacci, I'm the head of customer training at Astronomer and a best-selling instructor on Udemy, and my goal is to make sure that you are going to discover the most important concepts of Airflow, how to code your first DAG, and how to run it in Airflow. The only thing I ask you in favor is to subscribe to my channel. This will help me a lot, and don't forget to smash the like button. It is always good for the YouTube algorithm. Now, without further ado, let's discover what you are going to code in that video. This is the data pipeline you are going to code. First, you have three tasks: training model A, B, and C. As you are not going to train real machine learning models, you are going to return fake accuracies. Then, in choosing best model, you will select the best accuracy among all of those accuracies. As soon as you have the best accuracy, if that accuracy is above a threshold, then you will execute accurate, or if not, you want to execute inaccurate. This data pipeline may look simple, but it is not. Indeed, you are going to discover how to create tasks dynamically, how to choose one task or another according to a condition, how to share data between your tasks, and more importantly, how to schedule your data pipeline in Airflow. But before jumping into the code, you have to understand some very important concepts of Airflow. Let's begin with the first one. What is a DAG? DAG stands for Directed Acyclic Graph, which means it is a graph with nodes, directed edges, and no cycles. A DAG is a data pipeline in Airflow. For example, this is the data pipeline or a DAG. You have four tasks: T1, T2, T3, and T4. Those are the nodes. And the directed edges are the arrows, as you can see here, corresponding to the dependencies between your tasks. Basically, you know that T1 must be executed first, and then T2, T3, and T4. In this DAG, there is no cycle or no loop. In that one, there is a loop. As you can see, T2 depends on T1, but also T1 depends on T2, as shown by the red arrow. This is not a DAG. This is not a valid DAG, and you won't be able to do that in Airflow. You will receive an error. So basically, keep in mind that a DAG is a data pipeline in Airflow where the nodes are the tasks, directed edges are the dependencies between your tasks. The second important concept that you have to know is the concept of operators. What is an operator? An operator is nothing more than a task in your DAG. Let's take the following data pipeline. Here, T2, T3, T4, and T1 actually are tasks. But let's say T2 executes a Python function, then T3 executes a bash command, and last but not least, T4 inserts data into a database. Well, T2, T3, and T4 are tasks, but behind the scene, each task is actually an operator. For example, you want to execute a Python function. You will use the Python operator. You want to execute a bash command, you will use the bash operator. You want to insert data into a database, you might use the Postgres operator. So depending on the action you want to trigger from your DAG, you will use the corresponding operator. And Airflow has a ton of different operators. Keep in mind that an operator is nothing more than an object encapsulating the job that you want to run in your DAG. And each time you add an operator in your DAG, you are in fact adding a new task. That being said, you know everything you need in order to jump into the code. This is it. You are going to create your first data pipeline in 4 steps. But at this point, if you want to follow what I'm going to show you on your computer, you have to run Airflow on your machine. How to do it? I made a video about this. You will find the link in the description below. Now, once you have Airflow up and running, the first step is to create the folder DAGs where all of your DAGs will be. Once you have that folder, create a new file and let's name it my_dag.py. Each time you create a DAG, you need to create a Python file. Okay, the first step to create a data pipeline is to make the right imports. And there is one import that you will always make, which is the DAG class. So let's type from Airflow import DAG. You will always have to import the DAG class in order to say that this file is actually a DAG, a data pipeline. Once you have the DAG class, there is a second import that you will usually make, which is from datetime import datetime. Why? Because as you are going to see, a data pipeline expects a start date, a date at which we will say that the data pipeline should start being scheduled. So that's why you need to import datetime. Once you have this, you are ready to move to the second step. In the second step, you are going to create an instance of a DAG class. So let's do this. First, in order to create that instance, we can use the context manager with. So let's type with, then DAG as DAG and colon, like that. So at this point, we have successfully created a DAG object with the context manager with. And if you don't know what a context manager is, you will find some additional information in the description below. Once you have the DAG object, right there you have to put some parameters. And the first one is the DAG ID. Each DAG must have a unique identifier, otherwise you might end up with weird behaviors. So let's put a unique identifier, which is my_DAG. Then the second parameter that you have to define is the start date. What is the start date? The start date defines the date at which your DAG will start being scheduled. For example, let's say the start date equals to datetime. You have to specify a datetime object, then the 1st of January 2021. So let's put 2021, then 1 and 1. By defining the start date to the 1st of January 2021, you are saying that this DAG will start being scheduled the 1st of January 2021. Now there are two additional parameters that might be super useful for you. And the first one is the schedule interval. So let's specify a schedule interval here, put schedule_interval equals to something. The schedule interval defines the frequency, the interval of time at which your DAG is triggered. For example, you want to trigger your DAG every 10 minutes, you will specify this in the schedule interval. How? By defining a cron expression. A cron expression is nothing more than a way to define interval of times in Unix. Also, you have to know that Airflow brings some preset cron expressions that you can use. In your case, let's say that this DAG should be triggered every day. You can use the preset @daily. And if you are wondering what are the other presets, you will find this in the description below. Alright, there is one very important thing that you have to understand. In Airflow, this DAG with the start date of the 1st of January 2021 and a schedule interval to daily will be effectively triggered after the start date plus the schedule interval, which means this DAG is going to be effectively triggered the 2nd of January 2021 at midnight, after the start date plus the schedule interval. And since the schedule interval is set to daily, it is after the start date plus 1 day. That's how DAGs are scheduled. Now, what about the last parameter? Well, you have to know that each time a DAG is triggered, a DAG run object is created. What is a DAG run? It is nothing more than an instance of your DAG running at a given date. The thing is, by default, Airflow will try to run all the non-triggered DAG runs between the start date and the current date. So if the start date is set to 1 year ago and you have a schedule interval to daily, you will end up with many DAG runs and so many instances of your DAG. How can you prevent this? By setting the parameter catch-up to false. And by setting that parameter, only the latest non-triggered DAG run will be automatically triggered by Airflow. That's the only thing you have to remember with the catch-up parameter. It allows you to avoid ending up with many DAG runs corresponding to the non-triggered DAG runs between the start date and the current date. Alright, you have successfully created the DAG object. Now it's time to move to the third step, which is implementing the tasks. If you remember the DAG you want to create, there are 3 tasks to add first: training_model A, B, and C. Let's do this. Whenever you want to add a task in your DAG, the first step is to import the operator you are going to use. And in that case, you are going to use the Python operator to execute a Python function. So let's do this. Type from airflow.operators.python import Python operator. once you have the Python operator imported, just under the DAG object, you can create your task. Here, let's put training_model_a equals to the Python operator, and you have to specify 2 arguments at least. The first one is the task ID, and the task ID is the unique identifier of your task. You have to make sure that each task in a given DAG has a unique identifier. This is super important. So let's say training_model_a, and then a Python callable function. So the Python function that you want to call from that task. So here we put Python_callable equals to training_model. Then we have to create the Python function. So let's put def training_model. Then let's return a fake accuracy. To do that, we are going to use rand_int. So let's put return rand_int and 1 to 10. So a value between 1 and 10. And as we use rand_int, we have to import it right there. So let's put from random import rand_int. And that's it. At this point, you have successfully created the first task, training_model_a, calling the Python function training_model, returning a fake accuracy. As we have 3 tasks, we can copy that one, then paste another task here, and the third task right there. Then put B, C, and same for the task IDs, B and C. Like that. And you are done. You have successfully implemented the first 3 tasks. Okay, so what next? Well, you want to choose the best accuracy, and then if that best accuracy is above a threshold, you want to execute one task or another. How can you do that? By using the branch Python operator. So let's import the branch Python operator right there. And let's create a new task under training model C, choose_best_model equals to the branch Python operator, a task ID, let's say choose best model as well, and a Python callable function like with the Python operator, let's say _choose_best_model. Then once the branch Python operator is implemented, you can add the Python function. Let's type def choose best model. And here there is something specific that you have to do when you use the branch Python operator. Indeed, you have to return the task ID of the next task that you want to execute. Let me show you this. Let's say the next 2 tasks to execute are accurate or inaccurate. So let's create those tasks as well. Let's type from airflow.operators.bash import bash operator. Then under choose best model, let's create 2 tasks, accurate equals to the bash operator with a task ID equals to accurate and a bash command, let's say echo accurate, like that. You can do the same for inaccurate, so copy the task, paste it there, and type inaccurate, then inaccurate, and this time you want to print inaccurate on the standard output. So with the bash operator, you can execute bash commands, and that's what you are doing here. So the goal is to execute either accurate or inaccurate if the best accuracy is above or below a threshold. So how can you do that? Well, in the Python function choose_best_model, let's say we get the accuracy and the condition is if the best accuracy is above 8, then you want to execute accurate. So in that case, you return the task ID accurate. Or if it's not, you want to return inaccurate and so execute the next task having the task ID inaccurate. That's what you are doing here. If the best accuracy is above 8, then the task accurate will be executed next. If not, inaccurate will be executed next. That's what you have to remember with the branch Python operator. But there is something missing here. where do you get the value of best accuracy? Indeed, training model tasks return accuracies, so the question is, how can you get the best accuracy among all of those accuracies? Well, that's where you need to share some data between your tasks. And more specifically, you want to share the accuracies generated by training model tasks into the task choose best model. How can you do that? By using XComs. XComs stands for cross communication message, and I won't go into the details here, but it is a mechanism to share data between tasks in your DAG. So here, as we return the accuracy, the fake accuracy from each training model task, that value, the accuracy, is automatically pushed into the database of Airflow. Once the value is stored in the database of Airflow, we can fetch it back from the other task of our DAG. And that's what we are going to do right now. To fetch the accuracies from the database, we have to use a task instance object, TI. Then we put ti.xcom_pool in order to pull the accuracies from the database. Next, you specify the task IDs of the tasks having pushed the accuracies, in that case a list, as we have 3 different tasks: training_model A, training_model B, and training_model C, like that. Then once you have the accuracies, you can create a variable here, accuracies equals, and then select the best accuracy, create the variable best_accuracy equals to max accuracies. And that's it. At this point, you have successfully fetched all the accuracies and choose the best accuracy. Then, if the best accuracy is above 8, you want to execute accurate, otherwise you will execute inaccurate. Alright, you have implemented all the tasks. It's time to see what you get from the user interface of Airflow. So on Airflow, let's type Airflow to log in. And then, as you can see, you have the DAG my_DAG that you have created. If you click on it and click on Graph View, you can see all of your tasks. But something is missing here. Indeed, you don't have the order in which your tasks are going to be executed. You are not able to say that training model A, B, and C are going to be executed first, then choose best model, and last, accurate or inaccurate. So how can you fix this? Well, that's what you are going to discover in the last step. To define the order in which your tasks are going to be executed, you have to specify the dependencies. To specify the dependencies, go at the bottom of your file, and right there you can use the bit shift operators. With the right bit shift operator, you are defining the downstream task, whereas with the left bit shift operator, you are defining the upstream tasks. In your case, you want to execute training model tasks first. As you have multiple tasks, you can group them together with a list. So let's put training model A, then training model B, and training model C. Once you have this list of tasks, the next task that you want to execute is choose best model. So the downstream task of training model A, B, and C is choose best model. In that case, you use the right bit shift operator and choose best model. Next, you want to execute either accurate or inaccurate. So again, you can group those tasks together with a list. Let's create a list, accurate and inaccurate, as they are on the same level. Then, as accurate and inaccurate are both downstream tasks of choose best model, again, you put the right bit shift operator. And that's it. That's how you can define dependencies in Airflow. You can group tasks that are on the same level together using a list. So you put your tasks into a list, and then you can define the dependencies between your tasks using the left bit shift operator or the right bit shift operator. Don't hesitate to play with those operators to better understand the dependencies. Let's go back to the user interface, refresh the page, and as you can see, you obtain your DAG with the dependencies defined. Congratulations, you have successfully created your first data pipeline. And not only you have created your first data pipeline, but you also know how to share data between your tasks, how to choose one task or another, how DAGs are scheduled, how can you add tasks in your DAGs, and you know the most important concepts of Airflow. Let's schedule the DAG to see if it works. So turn on the toggle in order to start scheduling your DAG, refresh the page, and as you can see, your tasks are getting triggered. And now the DAG run is completed, everything works, Accurate has been executed. Oh, and by the way, you have created the training model tasks right there. But you can do much better than that. Can you tell in the comment section below how can you avoid repeating those tasks again and again? That's it for today. If you enjoyed the video, please smash the like button. That will help me a lot. I wish you a wonderful day and see you for our next video.